Maureen's out with Wally right now.
Hey, well, hello everybody. Welcome aboard again. It's the SBAU Astro Hour underway right now. It's a weekly Monday morning blog podcast, viewable on YouTube by members of the club as well as future possible members. For our South Coast longtime telescope and astronomy club, the Santa Barbara Astronomical Unit. Our headquarters and main meeting place up at Farron Hall, Santa Barbara's Museum of Natural History, a beautiful place up Mission Canyon. But for obvious reasons, we have not been able to meet there in over 2 years. This will be, ladies and gentlemen, episode number 78, about a year and a half's worth every week. August 22nd through the 28th, this edition, 2022. And I'm Baron Ron Heron, used to do this on the radio, vice president of the club. Going to introduce you to the crew here in a second. This hour, we're going to try to talk about the new moon, a nice dark sky this week. And incidentally, where NASA plans to land on that new moon in a few years with their Artemis program, their mission to the South Pole of the moon, if you can't believe that. An asteroid, a couple of nebulas. We're going to talk about a star cluster or two, some constellations. We got the comet in the sky with two tails, about to cross our orbital ecliptic. Then I guess they all have two tails. I didn't know that. And an update coming our way on an online September 2nd Friday meeting 2 weeks from now, featuring our own Chrissy Cook and Dr. Keyman, I guess it is, of UCSB, about to transfer south. Let's meet the president, Jerry Wilson. Hello again, sir.
Good morning.
I know you gave up presidency of your homeowners association to devote more time to us, and we appreciate it.
You're welcome.
I know you missed those contentious meetings out there where the swallows come back to Jerry's home. We also have Chuck McPartland, outreachable guy, our outreach coordinator. He loves it. And Pat's off to the side. His wife is Pat, and so is Jerry's wife. Different Pat. Pat Porgy is her name. Tom Whittemore, our bread baker.
Morning.
How are you, Tom? He's actually an incredible science instructor that they're going to have to do without, I guess, up at Westmont College, who now bakes bread, but not today. And his wife is Maureen. And incidentally, Chuck's wife is Pat McPartland, our merchandise person in charge. We got some silly stuff. We like to start off with Jerry's presidential forwarded silly science cartoons. You pick one and I'll try to match it, my friend, and show what you've been sending out. You gave us about 7 or 8 again, and I don't know where you get them, but they're funny. Some of them are funny. Others are just very illuminating. Here we go. That's the negative. Yep. You want to read it? Or that's the Apollo guy is on the moon. There's the limb in the background, and they want him to do something. And look at the way his hands are positioned. That's a negative, Houston. Atmosphere up here is too thin to play air guitar. Yeah, I could probably. Oh, here we go. Extraterrestrials. Recent theory, ladies, suggests UFOs, now called UAPs, are merely future time-traveling humans observing the past. And sure enough, there's somebody from the future saying, you know, this is boring. I don't see any Kardashians. Let's go freak out a 1950s farmer. Jump back down to marshy lagoon. And here are the, what did you call this? The Gordian cable? You're going to have to explain that. Depiction of a modern day problem. Large tangled ball of plugs and wires and connectors atop the stone monument pedestal. Whoever untangleth these cables is rightwise ruler of all the lands and peoples of the computing department. That looks like a closet at Chuck's house. Here's the rover on the moon. Oh my God, something goes splat right onto the rover's camera lens. The lady back on Earth at JPL says, good news, life on Mars. Bad news, no squeegee attachment. I'm sorry. On the moon. So splat on the moon. Poo-poo. Oh, here we go. Is this Calvin and Hobbes without the tiger?
Yeah, Calvin and Hobbes.
Yeah.
All right. He's trying to read a book in his bed at night. He suddenly goes weightless and he's floating around the room and he says, you know, I couldn't read it because my parents forgot to pay the damn gravity bill. Okay. That's a law you better follow, or that's what happens to you. All right. Thank you, Mr. President. You got it down. Talking to Tom Totten, our webmaster, last night on the phone. He called me and he says you seem to have gotten it down, and working out all these kinks. We got a lot to talk about. I like to start nearest the Earth, and that would be the new moon. This is a great week for watching the skies, I guess, gentlemen, setting up your instruments. Unfortunately, in about 3 weeks, it'll be half a moon at least, won't it, when we do the star party in September?
Half a moon is good, but it'll be full in 3 weeks.
Okay, last quarter, Friday, 8/19. That was Friday. It was last quarter.
I saw it come up last night.
You what?
I actually watched the moon come up last night. It was really beautiful.
About 2 o'clock or something.
That's right.
Yeah.
Some people go and look at the ocean. You look at the moon.
So this is the start as we get toward this. This is the start of the dark evening sky era.
Right.
So in my view, I can start trying to take pictures of the night sky, provided it's clear enough.
Jerry, just a plug for Venus. I did see Venus come up this morning at 5:48, but we're sure losing her.
Yeah.
Yeah.
Really?
Yeah.
Venus goes below for a whole half of the year.
Well, she's headed for the sun, to go around the backside of the sun.
Okay.
So it's very nearly full now. If you if you resolve it to see the disk, which, as you know, is very hard to do at night because the contrast is so high it just glares.
Yeah.
It's easy to try and find it during the daytime and observe it, but you got to watch out for the sun at this time.
Right.
Okay. And there are telescopes, I'm not sure if yours have the ability to do this, that block out the sun, that have a black disc.
Occulting disc, yeah.
Okay, does that come with every instrument you buy?
No.
That's a specialty item.
I was going to say it comes with a free pack of tarot cards. And occulting disc.
All right, Mr. President, what are we looking at here?
Well, this is under the new moon almost title. There are 2 Messier objects.
Oh yeah, right. Okay.
And this is a finder chart for those objects. This is, of course, Vega, the very bright star, almost overhead about sunset or as soon as it gets dark. And this trapezoid, this was the picture we used about 2 weeks ago. This trapezoid is the rest of the constellation of Lyra. And right between these 2 stars down here, as a matter of fact, this red thing is M57, the ring nebula.
The ring nebula is M57.
Yeah, which is this familiar object. Now, this is about what you see in a scope, but you just see in black and white, you just see this part out here. On our typical scopes, you can't see this core star, the white dwarf that's left over from it burping off the outside. But this makes a very nice object. You can scan that region in the part of Lyra. But if you're at a low power, say about a 25 millimeter eyepiece in our typical scopes, this will look very much like a star, and it's very easy to pass over. So you need to get in the right region and use a higher power eyepiece, say about 100x, and which is about a half an inch eyepiece focal length. And then it'll pop out. It's very nice. And if you use an O3 filter, which is ionized oxygen, then it will give you very high contrast between the planetary nebula and the background sky.
Can I ask a question about this picture?
Go ahead.
The red and yellow, which seems to be surrounding it, and we're looking face on to like a fried egg. Is it more like a complete egg and we're looking through it and it's on this side? It's totally around the blue.
Actually, it's hourglass shaped. And we're looking at the base of the hourglass.
But is the blue encased in a complete shell of that yellow red part? And we're just looking through that somehow.
No.
It's not a shell, but an hourglass? How in the world would we know that?
Because with Hubble, you can take spectra and see different red shifts and blue shifts in the gas as it's moving toward us and away from us. And they see 2 lobes, one moving away and one moving towards us. It's just that they happen to be sort of lined up.
Yeah, well, I've seen a similar thing with exploded stars, or long after, a hypernova or supernova, And it all looks like it's plastered out on the sky, and we're looking right at the center where the star used to be. Actually, it should be covered, shouldn't it? In the foreground, is it?
No, if you
like
if you look at a soap bubble, you see the edges of it because you're looking through more stuff. So you see a circle and then there's less in the middle. If it were a sphere, it would look somewhat like this.
Okay, well, the soap bubble is totally transparent, but a lot of that stuff isn't, that come, out of a star when it explodes.
Yeah, and that just emphasizes the effect that you're looking through more stuff when you look out near the edges.
But this is M57, huh? What's M56, Mr. President? That's another globular cluster.
Yep, it's a very nice globular cluster. This is also in Lyra. It's got a image. This is taken by a big observatory. It's got a defect in it, and that is the diffraction spikes around the stars are very long in the horizontal direction. And that's because it doesn't have nearest neighbor overflow capability. What do they call that? Bleeding. So that star image was saturated, and it flooded the detector elements that were in the same line of the readout. A minor issue. It still makes a stunningly good image. Don't get it wrong. I'm impressed with the image.
Imagine old man Messier found this during a no moon or new moon phase.
Probably.
Probably in the dark of the sky. He was looking for comets.
Comets. Yeah.
Nebula didn't pay off. Comets paid off.
Well,
And the skies were considerably darker than in Paris.
Yeah.
We were.
They used to have observatories in cities, and people would do their observing from their rooftop or even from a balcony. It was in the 20th century that people started building things really outside. They got a site specifically for the darkness and the weather. The only compromise of that I'm aware of is the Lowell Observatory in Flagstaff, Arizona. The guy built it. He was a multi-millionaire back in the 1890s, 1900s. And he wanted to have a really good site, but he also wanted to have bars and inns available around there because he did like nightlife. So Flagstaff was his compromise.
Some big square observatories being built somewhere. At least they're not dome shaped as far as I can tell. I mean, they do have a slit in the roof, but they're squared off. Maybe you know what I'm talking about.
Yeah, that one's Lowell Observatory.
Yeah, typically the squared off ones are on our roll off roofs. Very typically. We built one at Evergreen when I was still there.
Okay.
Some of the modern big ones are sort of more squared off.
That's true
And
too.
they open up just like the whole roof opens like a slit, like a roll off on each side.
Mm-hmm. And like a clamshell.
Yeah.
And down in Atacama Desert of southern Peru or northern Chile is the best sky viewing in the world. It's dry as hell.
Yeah. Very dry. Yeah, very dry.
Incidentally, let's talk about some of the planets we're also seeing out there. Mr. Whittemore, you got up and checked on Venus?
Yeah, I actually saw Mars come up too last night.
All right, well, Mars is early on. It's magnitude 0, which is as good as it gets, I guess.
Really beautiful, bright red, planet course.
And fairly near Aldebaran, right?
That's right. Yeah, in Taurus.
That's the red eye of Taurus the Bull. And in fact, Mars is 11 degrees above it. Betelgeuse is up there, 21.5 degrees below Aldebaran, magnitude 0.5, a red giant. And I think we established that's a variable star nowadays, isn't it? All three of them form a nearly straight line. This is good old Jupiter.
On Jupiter.
This just came out yesterday. I just saw this on the internet. It's a James Webb Space Telescope view of Jupiter.
Wow.
It's quite dramatic. I haven't read anything about it. I can't explain it. Of course, the Great Red Spot is there. I believe it was taken with the NIR camera.
And those are auroras there up at the poles.
Yes.
Huh. So we're looking at heat not so much light. Heat turns into light.
It's light.
with the web.
It's light.
It is
No,
light.
heat emits, heat is the oscillation of atoms. And you need a dipole to oscillate to emit light. So the hotter it is, the more vibration you get. And so the higher energy light that gets emitted. But everything is emitted from some form of heat. It's just been a colloquial pseudoscience thing to call infrared heat radiation. Everything radiates heat.
It's often called that because they use infrared lights to keep food warm at some restaurants. So they call them heat lamp. Or when you come out of the shower, you often have a heat lamp that you can turn on, and that's an infrared source. But it's not heat. It's just radiation. It interacts with water and makes it vibrate, and that you feel that as heat.
Mhm.
But I've seen a lot of pictures from the web that are totally colorful and colorized, and I guess they have to do it, don't they? They could colorize this picture we're looking
This
at.
is colorized. This is
It
false
is.
color. Everything you see from this is false color.
Well, I got to tell you, the red spot is not red.
Huh. Oh,
Oh, Tycho Brahe. Oh, I thought you were changing our.
no, I've got them arranged in order, and I just forgot the order.
Well, you want to tell us, Tom, where Venus is and how bright it is and what you see?
Because it's, sort of tracking the sun, it's on its way to the sun. And the sun now rises not quite east, but a little bit north of east. I see Venus north of the east point. Okay. And again, that's 5:48 in the morning for us because we have some hills out. It's certainly up earlier than that. Okay. But we have to wait for it to clear the hills. And I'm noticing Jerry's got Orion there. I see Orion at about 5 in the morning, just beautifully over the eastern sky.
Yeah, as you can see, this was taken at 5, or this planetarium scene is simulating 5 in the morning.
That makes sense.
It's what I listed under red things in the morning because it's got 3 red objects lined up, which is something to see.
Mm-hmm.
So Mars, Aldebaran, and Betelgeuse down here with Orion just rising.
Mm-hmm.
Would it be fair to say that man has been looking at the belt, the 3 stars in a row, for 1,000 years, and they haven't really appeared to move anywhere? They're the same.
Yeah.
There's a thing you can do with a planetarium show, and a lot of them, and I don't know if Palmer or if the museum's planetarium can do it.
Oh,
But
absolutely, it can.
It shows the sky at several millenniums in the future. And you can watch familiar star patterns become distorted and then unrecognizable.
We're all going some direction. But it's even fast, it's still too slow for us, or at least it doesn't show.
It's slow on a human lifetime scale.
Right.
Yeah.
But you'd think something would have happened over a millennium, 1,000 years ago. Weren't they?
Well, if you go back to the pyramids, they were aligned to a different North Star.
Mhm.
Mm-hmm.
Really? Which one was it? Vega?
No.
Too bad.
Oh, okay. It's going to be Vega in the future, I hear.
In about 12,000 years, yeah.
Yeah.
Okay.
It takes about 25,000 years to go through the whole cycle of North Stars.
You suppose back then Betelgeuse was not a red giant? It was like our sun, or maybe?
No, it was probably still red. I mean, that's millions of years for that kind of stuff.
Oh, was that right? Fantastic. All right.
There's some star that was referred to as, in ancient writings, was referred to as ruddy, meaning red. And today it's not red. And people have been trying to figure that out. Because something going red and then becoming bright white is not the pattern that stars do.
Wonder why they are red. Why are there red dwarfs?
That's the surface temperature.
Yeah.
They're that means cooler. The blue stars are the hot
Yes.
ones.
Yeah. Cooler. Cooler is red.
Okay.
Hot is blue.
Okay. How does a Webb look at a hot star then if it's all in the infrared? It's just probably too bright, I would imagine, for the Webb telescope.
And what you see on the screen now is what you will see about 6 months from now in the evening sky. But it's just coming up right now, or on this time of year, it comes out in the very early morning.
Well, I can't read a lot of it is, I don't get too close to the screen to read it. But
Too small?
yeah, can you increase at least? There you go. Oh, there's Aldebaran. Okay, M1 is over here.
Yes.
Crab Nebula.
Yeah, the
Oh.
crab.
Now, the crab is one of the things you were talking about earlier, a supernova explosion, and it just blows everything in all directions, and you get these webs of things. There's some very big remnants of nova and supernova explosion in the, what is that? The Veil Nebula area and the Gum Nebula in the south. But these planetary nebulas, when a star throws off its outer shells, it's not a spherically symmetric event. The star has a magnetic field, and that helps define the pattern of what's thrown on, and it's rotating. And it's changing its rotational speed because it's shrinking and it's increasing, which affects its sort of eruption pattern, you might say.
And also most are binary.
But that's right, most are binary. So there's a lot of reasons why you should not expect a simple bubble, expanding bubble of
From a planetary nebula.
yeah, right.
You mean they become binary, or they're one of the two stars in a binary that blows
One of the
up?
two stars in a binary system that's reaching the end of its life.
And there's a reason for that?
They got old.
Yeah.
But well, more than half the stars up there in the sky, even though we can't see it with a naked eye, are binaries. But
Yes.
That's
And
the
that's why,
reason.
and that's why these planetary nebulae often have bilateral symmetry, like the hourglass shape.
Hey, Ron, just a little point here. So El Nath, you see that star over on the left, El Nath? So that's
Oh, yeah,
one,
right.
one of those little rare creatures that shares constellations. So in Arabic, it means the butting. And it's shared with Auriga, the chariot driver, and Taurus, the bull.
Yeah, it's right on the border.
Yeah.
that star is part of Taurus. That's my son.
Part of
I
Taurus.
think officially it's part of Taurus, but it also is part of the sort of asterism that forms the charioteer.
Yes.
Yeah, Auriga.
It's too bad we
And-
can't get the pictures surrounding some of these stars like at the planetarium.
Well, we could. I mean, Jerry could turn that on, but it gets, it kind of overlays a bunch of the information and makes it harder to see.
Yeah.
Oh, yet
And
they're
those
all over-
Messier objects, Ron, those Messier objects, M36, 7, and 8, are just beautiful open clusters. They go right through the core of Auriga. Okay, I always show those at Westmont.
Gotcha. Well, do you want to go to Constellation Serpens?
Serpens, the interrupted constellation.
It says it broke it into two parts, and the only one that is, and we're going to concentrate on the head. That would be
Kaput.
Serpens kaput.
Maybe that's where the word cap came from.
Well, it certainly gave me kaput. If something's kaput, it's the head of the serpent, right? Serpentine, serpent cauda is the tail,
Yeah, Latin for head.
and it's Ophiuchus, the serpent bearer,
Mhm.
carries the celestial snake across the sky. Tonight, concentrate on the head. Is that it?
That's the head.
That's the head of the head.
Not
This goes
regular.
down and then it's chopped off because it's being carried around here.
Yeah.
Oh, I can't get far enough down for it.
And the tail of Serpens is in the area of the Poniatowski's bull that we talked about a couple of times ago.
Here's a couple of interesting names, Yed prior and Yed posterior, but they're both in the same plane, so I've never figured it out.
Well, that's because one shows up first, in right ascension.
Right.
Well, that could be it.
Mhm.
But somehow those three stars forming a triangle at the top make a head. Okay.
Well, it's a head and shoulders.
Yeah.
Oh, you mean the head of the snake? Yeah.
Yeah.
I look at the head of the snake as an X. That's just kind of how I always looked at it.
Well, in real
Oh,
life,
where's the other, like there and
Mhm.
yeah,
kind of.
it's got to be a poisonous snake. Then they have flared heads.
Wide jowls, yeah.
Yeah,
Yeah.
but no rattles on the other end. Fascinating.
Okay.
Okay. You want to do the asteroid or the comet?
This is the comet.
This is
Do the
oh, okay.
good old pan stars?
Yeah.
You got some great pictures today. Friday night,
I
the
think
comet with
this
two
is pan
tails and
stars.
the good old C27K2 lies near between the two neighborhood stars, Scorpius, Arcab and Dashuba. And the comet is at magnitude 9, I believe, is northwest of a line drawn down those two stars.
Yeah, Ron, just a technicality, you don't pronounce the D in Shuba. Okay, it was the star of the month last month.
What language could that be with a silent D?
Arabic.
It's Arabic, but you don't pronounce the D, just like Shuba.
Just Shuba, okay.
Mhm, mhm.
Yet they use the same letters we have. They don't use letters, they use little squiggles and things in Arabic. I don't
So
understand.
this is not the comet. This is 4 Vesta and the Helix Nebula. And the target here, this is the illustration for that. This is the Helix Nebula, which I couldn't get to show up on the planetarium, so I just put the cursor there. This is right, and so you get the asteroid 4 Vega and the Helix right together. The Helix is another planetary like the Ring Nebula.
Actually, it's 4 Vesta.
No, we're talking about the nebula now, Ron. It's
Yeah.
near 4 Vesta.
Yeah, 4 Vesta happens to be just cruising by the Helix Nebula. This is the Helix Nebula.
Yeah, okay, but it's near 4 Vesta, the asteroid. That's what your notes say.
Yes, yes. The asteroid is near this object in the sky. This
Right.
is very hard to see because of the low surface brightness.
Mhm.
And it's huge.
Yes, it doesn't have a Messier number. It's got an NGC number.
Mhm.
That would be 7293.
Yeah. But it's got a very similar appearance to the Ring Nebula. So, and you can see a lot of these, it apparently had some debris around it that when it was sort of slowly expanding, and when the thing shrugged off its outer layers, that shock wave ran into them and passed them by and left these streamlines.
Well, are we looking up through the bottom of another hourglass?
Looks that way.
Yeah, probably.
Well, so that's going to be the bottom part. An hourglass is kind of like two rocks stuck together, you know.
Right, right. And we have seen some planetary nebulas from the side that are very clearly that way.
The dumbbell.
Oh,
Yeah.
okay.
And the Ant Nebula,
Yeah.
The Ant Nebula.
which does not look like an ant to me, but
But my question still holds, that purplish part that seems to surround it, is it also in the foreground and covering it and we're looking through it?
you mean
Yeah.
this stuff up here?
Yeah, is that also across the blue part, but we're looking
Yes.
through it somehow? Or why do they always open up and let us see inside? It looks like a
Well,
donut.
you're looking through less material.
Right.
Right.
Okay, but if we were off somewhere else to the side, we'd see the same thing. We'd be able to look through.
If it were
Stunning.
perfectly,
Yeah.
if it were perfectly spherical, you'd still see the similar type of thing.
Yeah.
Right.
Because, yeah, because,
But if it's asymmetrical, you'll see a different pattern.
right,
Well, is there a white dwarf at the center of that or
Right there.
Yeah.
right there.
sorry, you don't see it, do you?
Yeah.
You do?
That's it.
Big enough telescope, yeah. This is not a terribly bright exposure. This is a very, object. This is a very bright, very long exposure. But I lost my train of thought. Go ahead.
Well,
Yeah.
the-
Go ahead, Ron.
The white dwarf would be at the center of the two globes of the hourglass then, right?
Yeah.
Yes.
Mhm.
Why does it blow? It blows in two directions, not all directions?
Well, if it's got a binary orbiting it, that channels the outflow
Mhm.
It does.
perpendicular to the orbital plane. Or if it's got a strong magnetic field, that can either be aligned with the rotational axis and you get a nice bipolar shape, or the magnetic axis could be offset, in which case you get something like the Cat's Eye Nebula that just looks like somebody left the sprinkler on all night.
But the partner star in a binary, when one of them goes up, it gets eaten alive and becomes part of it, or
No.
still out there orbiting?
Yeah.
Okay.
It just hunkers down and lets the stuff blow by.
Maybe
Got it.
sucks up some of it.
Yeah.
But that's not to say that single stars that are not in a binary won't also blow up.
Right.
Right. Okay.
Ours will do that. Matter of fact, ours will probably look something like this in about 5 or 6 billion years.
Well, all of us are made of stuff from one that blew up before our star.
Yep,
Mhm.
that's where heavy elements beyond helium came from.
Exactly. That much I learned so much from this program.
Yeah, just an aside, Ron. So these objects are more easily seen through an O3 filter. Okay, an O3 filter, which is twice ionized oxygen. It's a green line.
Well, I knew that. I knew that, Tom. You didn't.
Yeah.
And your eye's a lot more sensitive to green.
Yeah.
Yes.
And that's part of why they call these things planetary nebulae, because they were sort of studying them and finding them at the same time that they had found the planets Uranus and Neptune,
Right.
which look greenish. And so they said clouds that look like planets, planetary nebulae, but they have nothing to do with planets.
Mhm.
If we're looking at a Hubble picture or a Webb picture, can you get something like this from a ground-based telescope?
Oh, yes. Matter of fact, this is probably taken.
Not that spectacular. I've seen it in my 18-inch telescope with an O3.
Mhm.
It's like Chuck said, it's a huge object. It really spans quite a bit of space.
But it's not a Messier.
Yeah, 'cause
No.
it was too dim for him to see.
Yeah, it was an NGC. It's an NGC object.
And Helix is a nebula. It's not a constellation.
Mhm.
What about the asteroid?
I think
part?
of it more as the viewing in the winter time myself.
Speaking of asteroids, you can leave that picture on the screen. Have you done any occultations lately, Mr. Outreach Coordinator?
Not for about 10 days or so, but there's one coming up this week that's pretty high probability if the weather holds.
Okay, well, what can you tell us about 4 Vesta? Because that was, along with this nebula, the beat of Jerry's story when he sent it out.
It's a big, early, bright, early found, number 4 of the asteroids found. So it was considered a planet in the 1830s. And it's the one that the Dawn mission went into orbit around and studied, and it's kind of shaped like a walnut.
Does it ever occult anything, a star?
Sure.
Oh, it does.
I haven't seen any Vestas that I can recall, but
But we track it just like we'd track Mars or Saturn, or it travels in the asteroid belt.
yeah,
Our focus on tracking asteroids, we track them all, but our major purpose is to find near Earth objects that might be dangerous.
Right. Oh, okay. And then the comets, I'm not sure if you want to switch over to pan stars with 2 tails. Apparently they all have 2 tails. But this Friday
Let's
night,
go in order through these things, because I finally got smart and lined up the pictures
oh,
according to the pattern of the talking, so I can flip from
tell me
each
where to
one
go.
without having to shuffle the deck.
All right. So what are we going to talk about now?
We're going to talk about Hercules, a constellation that oddly enough, it's easy to find. It's got another little truncated triangle or trapezoid here. I don't notice these arms too much when I find that that's not my recognition pattern.
yeah. This is a weird line drawing for it, because usually that arm sort of going off to the left by M13, that's part of a bent knee down there.
Right.
And the other leg is standing almost directly on the head of Draco up above.
Yeah.
This is, yeah.
But this
Anyway,
is
people
this is
do
called the
different drawings.
keystone. Yeah, this is called the keystone. And the
Mhm.
neat thing about it is that it's an asterism that's easy to find with your unaided eye. And 1/3 of the way between this star and this star is M13, right on the line. So you can point your telescope right there. If you have GoTo, you just plug in M13, enter. So, and that is in a nice area of the sky for lots of other objects. It's a little west in the evening. It's a little more toward the horizon than the Lyra up here with the M57 in it. This is going to set first. And this is a picture of M13. Now the M13, there's kind of a dark streak here, and there's kind of a dark streak there, and there's kind of a dark streak here. This is a photo, and so it shows a lot of brightness. But these dark things, you can see visually, it gives you the effect of a three-pronged propeller here. And that's a feature of this globular when you look at it in a telescope.
Propeller?
What?
You said a propeller, a
A
three-pronged?
propeller, yeah. It looks like it has a fake propeller in it. The human eye's imperative to find patterns.
Apparently, the whole thing has a volume of less than 150 light years across, but it's got thousands of stars.
A million.
one-
roughly.
Million,
Yeah.
yeah.
I read about 250,000. Bruce always corrects me when he's on there to be a million or more.
Yeah.
So which one's right? It depends on what you read.
Yeah, I think the newer counts are higher.
Yeah. Everything seems to be going that way. Our galaxy suddenly jumped from 100,000 light years across to close to a million, depending on how you find the edge.
Yeah.
Now,
I keep hearing 200,000 for that.
Okay.
Really? So the 150 light years across is erroneous? That's not right?
No, that's right.
Oh,
Yeah.
but the number of stars within there.
Yeah.
Okay, that means they're almost all binaries or whatever. They're
No,
I'm
it
not-
just means they're all in a small space.
Yeah. I'm not so sure binary star system really counts in this.
Yeah. It'd be
Really?
harder to be stable when you've got so many neighbors that are tugging on you,
Mhm.
we're talking
Someone-
light months apart, not light years,
or maybe light weeks. Yeah.
light weeks.
Someone modeled, years ago, I read an article where someone had modeled the effect of a planet around a star in this system. And with the random motion of the stars, the planet did not stay loyal to any one star. So,
Oh,
I
decide
think
to go-
binaries and trinaries would be in the same category.
I don't know why we don't see collisions more.
You
on
do.
stars or planets. I mean, they orbit faster and faster and faster. And
Well,
finally-
Space is largely empty, but in these kind of objects in globular clusters, you see what are called blue stragglers, which is a star that's anomalously young and bright looking. And that's caused when these old stars here collide with each other within the central parts of the globular cluster.
So the white stars there, Baron, are ones that have collided.
Oh, and they don't just blow up, they merge and become one, bigger,
Right.
brighter. And would make the LIGO gravitational wave detector maybe wiggle a little?
I don't think those are massive enough to, well, maybe they are.
I don't think the LIGO is sensitive enough because these aren't that massive. Yeah.
They look at 30 solar mass black holes. They see those with LIGO.
And these are going to be low mass stars because they're very old. And if they had high mass, they would have already gone through their lifetimes.
Right. So, and I don't know that every white star in there does, but I can't tell the difference.
Yeah, anyone that's bright blue in there is probably a merger condition, but the white ones might be ones that are still hanging on the main sequence.
Oh. This is Hercules.
And
This is
Robert,
Hercules.
The
Yeah.
Great Nebula, or no, that's different.
It's called also the Great Globular Cluster in Hercules, or the Hercules.
Right,
cluster,
right.
yeah.
Hercules is the constellation, and this is the globular in it. There's also a Hercules cluster, but that's a cluster of galaxies. And
yes,
I can remember once in the planetarium in the lab outside, they had photographs taken by students at Goleta Valley Junior High using the telescope out at Sedgwick. And that was their science project.
Mhm.
And they had a bunch labeled the Great Globular and Hercules, but they had actually taken pictures of the galaxy cluster.
Huh. Well, here's the part of your notes that you sent out that confused me. Maybe you can explain this. By fall, the easiest constellation to see up there, Hercules, will be lost, or at least, let's see, one of the best globular clusters in the northern sky. I remember writing this down, M13, 75 degrees high in the western sky. Which is it, northern or western? Why did both those?
It's in the western part of the northern hemisphere sky right now.
That's what that means. Now after sunset.
And when I mentioned that it will set before Lyra does, Hercules will set relatively soon. It's in the evening sky toward the west. And in a month or two, you won't see it at all. As we
Well,
get
it's nice and high right now. It's still
Yes.
way high in the sky, but yeah, it's moving by 4 minutes each night. So
So all the globular clusters are, of course, contained in our Milky Way. Do we see them in other galaxies?
absolutely.
So they're the little brighter, larger white spot, I guess, aren't they?
Mhm.
Now, these globular clusters orbit around our galaxy, but not in a plane and not in the plane of the galaxy. They occupy a spherical shell around the galaxy.
You're kidding.
They
Really?
were one of the first clues of where to look for the core of our galaxy.
Yeah.
Right.
So this basically how globular clusters formed, why they stay together, and how they got their orbits is a research topic.
But they're basically little baby failed galaxies that were forming when we were, and we just sucked away all their material.
Could be.
Aha. So some of those satellite galaxies between us and Andromeda are large versions of this, right?
Yes, and some of these some globulars, like especially Omega Centauri, may be the cores of galaxies we've gobbled up.
Wow. Fascinating stuff.
Okay, shall we move on?
Yeah, let's do the comet with two tails. And I defy you to show me all past comets with both of their tails. They kind of spell out 828 on a clock. You look at them there, Pan-STARRS, also known as C/2017 K2, lies between, let's see, Suba and Arcab. No D on the.
Oh, that was a typo. It should be Acrab, not Arcab.
Oh, it wasn't. Okay, my apologies.
Well, no, it's got a typo in the
Text.
text.
So it's iCrab?
It's ACRAB.
Oh, ACrab, like, oh, that's interesting. All right. Northwest of a line you draw down with those two stars, also near M80, magnitude 7 globular cluster. We're back to that again, spanning 10 arc minutes across. That's not very big. It's less than a degree, 4.5 degrees southeast of the comet Pan-STARRS. And
This is where the comet is midweek here.
I see.
This is the head of the Scorpius.
Okay.
And Terry's another globular cluster, M4, M80, which you can compare. Well, they'll be in different fields of view, but you can compare them for brightness. But the comet is moving this way. And I think it's closest approach, but not its brightest. It's past its brightest to us, the closest approach to Earth, but the closest approach to the sun will be in December, and it will be well out of this constellation.
Do you know how bright it is, Jerry?
I do. 9th or 10th magnitude right now.
Oh, okay. So kind of out of the reach of my binoculars. Yeah.
Well, does it literally cross our orbital plane, or is it above it or below
Yes.
it? But
It's coming in from above.
Wow.
okay, will it
If you
go
take
back
north
out?
as above.
So this is the one that we got from space.com.
Space weather.
Space weather, thank you.
Anybody want to explain how we get the two tails? What's the difference? What produces one? What produces the other?
Go ahead, Chuck.
One tail is ions, charged ions being swept away by the solar wind. And then the more prominent tail here is the dust tail, where it's dust particles that are also affected by the solar wind, but not as much. And they more follow the gravitational path that the comet followed.
Could you tell which is which by looking at this photo?
Yeah, the ion tail is the one coming downward,
Okay.
the sort of fainter one. And then the dust tail is the other one. The dust tail tends to look more yellowish and the ion tail more bluish.
But if we were to pass through that tail in the future, it would be a radiant of meteors, wouldn't it?
The dust tail, yes.
Yeah,
Just the dust tail. The other one's totally different.
Yeah.
we'll get to that. Yeah. This is a wider field shot that shows its proximity to some nebula and the stars. And I believe this was taken earlier.
Mhm.
So very dramatic pictures.
And what's the story on Pan stars with 2 R's? And
That's an acronym for the telescope.
Right, the robot that found it.
okay.
These are pictures of the south pole of the moon.
Ooh, here we go.
None of the craters I recognize because I've never seen them from this angle. But 13 candidate sites have been released or identified and released Friday of last week. So these are the candidates where the Artemis 3, the first touchdown on the south pole of the moon, will occur at one of these sites. And the actual site will be selected much closer to launch, I believe in 2024 or 2025. And it will be chosen largely on the basis of the launch time for the launch schedule for the mission, so that launch sunlight and launch condition on the moon is favorable. So,
Okay, and there's water up there frozen inside a crater or two.
they're not trying to land on the water, but they're trying to land in regions where there is both light and nearby darkness, so they can explore both of them. And they will, I think they're going to, of course, Artemis is a manned mission. I don't know if the Artemis 3 will be manned, but I know the Artemis in general will be manned missions.
Can
So
you enlarge that? Can you
what's that?
enlarge that, Jerry?
Oh, yeah, sorry.
Oh, well, don't be sorry. I managed to count 13 of those little blue squares.
Yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
13. Some of them overlap.
Uh-huh.
And there's several sites within each of the 13 squares in there. So there's dozens of places they might be landing.
13 places they might be landing.
Wonder if there's some lava tubes in the vicinity too.
Maybe, but they're not looking specifically for lava tubes. They're exploring the local terrain and the weather conditions in terms of sunlight. So,
And you can bet they're looking for places that, in addition to those conditions, have a nice flat looking spot where they can land safely.
right.
But they will see the sun on the horizon, won't they?
Yep.
Yes.
And something you said in your notes led me to question something about not disturbing. Yeah, not disturbing. What does that mean? Did Apollo disturb the moon and we don't want to do that now?
I don't recall that phrase, but I
Put it down, not to be disturbed.
Might be a golf ball up there, Ron.
Yeah.
That golf ball may be in orbit by now, but long shadows. And that's going to be interesting. Within a couple of years, is that what you're saying? It won't be next decade?
Oh, no, it won't be next decade. They're planning on it in 2 or 3 years.
Were there 10 flights before Apollo 11 landed that just went out and circled the moon? I don't think we had Apollo 1, 2, 3, 4, 5, did we?
Sure.
Yeah, we did, but they weren't all manned.
Oh, the first ones didn't have people on board.
Well, the first one was a disaster that killed the 3 astronauts, but then after that, there were a couple that were unmanned.
Well, that's right. And then 13, 2 after Apollo 11 was also a disaster that
And that thing about disturbance, Ron, they meant was they want an area to land where they won't stir up a bunch of moon dust, basically, that will then land over the shadowed areas where they think there might be water ice sequestered. And so they want to go collect undisturbed samples in those craters. So they're going to try to land not right at the area of interest, but a little bit off, and then go to the area of interest.
And obviously that water is frozen, so they're going to just knock off some chunks of ice.
Or collect some minerals that may be hydrated and have ice crystals in them.
It might not be just like a glacier.
Yeah.
But they
So
don't
this
plan to
picture,
drink
moving on, because we're running out of time.
it. Oh, yeah.
This is what's called, what was labeled a meteor wind, because the radiant is off to the right. For the Perseid, I think, meteor shower. This was the astronomical photo of the day a short while ago. Very interesting, showing over 2 nights captured different meteors, and it describes the effect that we're talking about now about following pan-stars. When we sweep through the orbit of a meteor, it acts like we're going through a windstorm of dust grains. And the size of these meteors, the typical line in here is probably a grain of sand, and something like this would be about the size of a marble. So, or a small pebble. This is not a meteor, this is the Andromeda Galaxy. Oh yeah, it says it that, yeah.
That demonstrates to me, Mr. President, how powerful Einstein's E = mc squared is to get that big of a view, that streak out of a damn piece of sand.
Well, this isn't really doing E = mc squared. That's nuclear reactions. This is just straight chemical stuff.
Yeah, this is not relativistic speeds, but it is going very fast. They're probably doing, what, 30 or 50,000 miles an hour?
Yeah.
But
yeah.
None of them survive, right? They get vaporized, don't they?
No, well, I mean, they get vaporized, but that's depositing atoms into our atmosphere.
Yeah.
But a lot of them just decelerate and come back down as dust.
Okay. They never did find that one that came down over Utah the other day, did they?
Not to my knowledge.
Never's not over.
Yeah,
but there was a big one that hit somewhere in the South Pacific that Avi Loeb, Mr. Oumuamua is a spacecraft, is talking about going and dragging a big magnet under a ship and trying to recover it from the ocean bottom.
That's good. That ship will be stuck there for years.
Yeah. Well, I think this is only 3 feet across. This was the one that was an earlier intergalactic meteor that hit. And the data weren't released because it was data from a Navy radar system. And they didn't want anybody to know that they had the resolution that they had and the abilities they had. But it was recently declassified. So it actually was the first intergalactic or interstellar visitor that they know of for sure, but didn't get the I-1 like Oumuamua did.
Obviously, we're not one of these countries that saw this meteor shower as good as we did or as they did. Australia, Armenia, Ireland, UK, Peru, it just goes on, but we're not mentioned. We have too much light here. And that's Tunisia we're looking at, I guess. About an hour's worth of stop motion, or what do they call it? Time lapse. You want to go to ancient history quickly before we terminate?
Sure.
The unsung milestones of astronomy finally getting some singing. Here we go. This is an ancient observatory about 600 years old. This is
Caracol in Mexico. It looks like an observatory, a modern day observatory, but it wasn't used that way. These ancient observatories, pre-telescope, they were largely timing devices, things like Stonehenge. So when certain things lined up between the cracks, the sun lined up between the cracks of 2 stones at a certain time of the year, that was how they could tell that that there was some event, either a festival or midway through the winter or time to plant the wheat, something like that. And these observatories went beyond as they progressed in their age of when they were built. It's too blurry. This is one in Uzbekistan. They started actually doing very accurate measurements of not just the sun and major events, but they started actually doing stars, trying to make star maps. And this is one of those kinds of observatories. There's an aperture here that they would look through, and then inside there is a long scale. And where you would move along this scale in sort of a chair with a fixed thing, and when you saw the star through that aperture, you could measure where you were down here in terms of an angle, and it would give the elevation of that star. So they recorded things in terms of elevation, and then the thing was lined up north-south. And as north-south is changing, you can note these things are no longer slightly lined up with north-south. So that's one of the ways we can tell that these things are changing a lot, or that the pole is shifting.
And can estimate when they were built if you don't know.
You what? Oh,
You can
yes.
estimate when they were built if you don't know.
Yes, exactly. Now this is
Tycho.
This is Tycho Brahe in Uraniborg with his great quadrant, and this is the ultimate technological development of the quadrant, of that technique. And through there, you see a star come down, and this guy is looking at it. And in order to see it through there, that star, he has to move. If the star is way up here, its light will shine down there. So it gives him, you don't have to look through an aperture like this. You can have a sighted stick and just point it at the star. And that's what you see on, you can't see it real well, but on this one up here. These are some of his other instruments. Another quadrant type is up here, and that's exactly what you have. You have a stick down here that marks the position of the star in angle, and then you just point that at the star and you measure it. He made the most complete empirical database of star positions, and
particularly of Mars positions.
yes. And the data was so accurate that everybody wanted it, and he wasn't releasing it because he knew how valuable it was. But after he passed, as we discussed, I think 1 or 2 weeks ago, Kepler got a hold of it, and he was able to go through and synthesize the patterns in that star data, because the star data was accurate. And that's where he came up with his 3 laws of motion. So these are all lined up, all these types of things are lined up so that when you swing here, you're swinging along the north-south axis. And this process was continued after telescopes were developed in telescopes called transit instruments, where the telescope would swing up and down, but only along a north-south axis. That became the most accurate sighting device for astronomical positions. And that was the major role for astronomy up until comets started getting discovered, and the major role was timing, because they needed to find out, the navigators needed to know when it was a certain time. They'd sail into a harbor, for example, Sydney Harbor, at 1 o'clock every day. The observatory would fire a cannon, and that was the 1 o'clock time. Then everybody set their ship's clock to it. So then by measuring the height of the sun and where it was in the sky along the north-south axis, they accurately determined when noon was, or 1 o'clock, or whenever it was. So these things were largely for data gathering.
Right. I think, Chuck, haven't you been to Greenwich?
Yes.
Yeah, I thought so. Mm-hmm.
Yeah, you can stand there with 1 foot in the Eastern Hemisphere and 1 foot in the Western Hemisphere.
Yeah. You can buy a t-shirt and a coffee mug.
Yeah. But a quadrant seems to be based on a quarter circle arc.
Yeah.
Yes.
Mm-hmm. Mm-hmm.
And they determined north-south by just looking at the star, which would probably be Polaris, even back then, that didn't move.
Polaris is off by 1 degree, but they can adjust that. What's that?
The fourth?
It's about 3/4 of a degree off.
Okay. I round off.
Yeah.
So they weren't, did they use it nevertheless? How other, they didn't have compasses back then, did
Sure,
they?
they had compasses way back, but those were magnetic north.
Yeah.
So somehow they discovered with the metal thing that's on a turret that it would always point north. Interesting. And Tycho is a one big guy there, bigger than the other two in the foreground of this
They
photograph.
show people according to their importance in this picture, just like they did in Egypt, where the king is real big.
Yeah.
And the little statue is his wife at his feet.
Yep, you're right.
And he had he built this whole basically palace that was oriented around various instruments.
Mhm.
It had
It wasn't
multiple
on an island, was
stories.
it?
And
Yeah.
supposedly he had a pet moose.
Oh, for crying out loud.
Definitely had a dog.
Yeah,
Yeah.
sort of a monkey face dog there.
Yeah.
Anus something or other.
Well, we do cover it all, gentlemen. The ancient history, the new stuff that's coming our way, and what an exciting science this is we're involved in. Makes you wonder what the people that are geologists are talking about these days. Oh, I found a new rock. Look at this sucker. We'll do it
I'll say
again.
if you look online for meteors, they're quite expensive. It's a real cash hobby.
Yeah, they've really accelerated in price after all these meteorite hunter TV shows went on.
Yeah.
They still finding them in the ice in Antarctica, you suppose?
Like crazy, yeah.
But they do. Well, you've taught me a lot, gentlemen. Thank you very much. Take care of your wives and your health, and stay alive. And maybe we'll see you live someday on a first Friday. Otherwise, we'll join ourselves together in our dens and our man caves next Monday morning for the SBAU Astro Hour number 79. Thank you, Tom, and thank you, Chuck, and thank you, Jerry. We'll see you next
Bye.
week.